First section of chapter 9, applying the distance and midpoint formulas. Now, hopefully you remember those formulas already. If you don't, here they are. Make sure to get them into your notes. The distance formula, remember, you take the difference of your x quantities, of your 2 points, and square it, and the difference of your y's and square that, and then add it together and take the square root. Where that comes from, this is coming from the Pythagorean theorem. So if you've got a point here and a point here, and you're looking for this distance, what you can do is create a, oh, that's just a lovely picture, create what is this called? A right triangle, and the distance between the x's, the distance between the x's is here, and the distance between the y's is here. And so what we've done is we found this length, and we're going to square it, and we found this length, and we're going to square it, and added them together. And so remember the x squared plus y squared, or a squared plus b squared equals c squared. So that's the a squared plus b squared equals c squared, and that's why we take the square root of it. Anyway, that was a quick reminder of where the distance formula comes from. So that's what that is. The midpoint formula, remember, is if you add the two x's and divide by 2, and then add the two y's and divide by 2, that gets you to the middle. So if you add your two x's and divide by 2, and then add your two y's and divide by 2, that gets you to the middle of that line. So let's work a couple. If I want to know what is the distance between these 2 points, all you're going to do is plug it into the formula. We've got a formula. So the distance, if I want to know the distance between these 2 points, I'm simply going to plug in and say I want the square root of my x's subtracted. Now here's the deal. You can call this one number 1 and this 2, or this 2 and this 1. It doesn't matter as long as you use the same one first, because we're finding the difference. When you're adding, it doesn't matter which one is first. When you're subtracting, it matters. So let's just say 4, this is number 1 and this is number 2. So 4 minus a negative 3, and we're going to square that. And then we're going to take a negative 1 minus 5, and we're going to square that. So 4 minus a negative, remember, is plus. So 4 plus 3 is 7 squared is 49. And negative 1 plus negative 5 is negative 6. Negative 6 squared is 36. And we want the square root of that. And so our distance is the square root of 85. And you can stop there. Square root 85, done. Easy sneezy. So for the distance between 2 points, all you're going to do is plug it into the formula and do it. Now there's another section where it says, well, what if you have a triangle and this triangle has these vertices? Is this triangle equilateral, isosceles, or scalene? This really is just a ploy to get you to use the distance formula more often, don't you know? Okay, so in order to find out, well, what shape of a triangle is this? You remember equilateral is the same length, isosceles has 2 that are the same, and scalene are all 3 different. All you need to do is take these 3 points, find the lengths of all 3 sides. You could either plot them and get out your ruler and measure them, or you can simply use the distance formula 3 times and compare your 3 answers. Let's do that. I think that's quicker and easier. The distance between the first 2 is negative 2 minus 2 squared plus negative 2 minus 1 squared. So negative 2 plus negative 2 is negative 4. 4 squared is 16. Plus 2 and 2 are 2 and 1 are negative 3 squared. 3 is 9. And so this is going to be the square root of 1925, which is 5. So that's the distance between these 2 points. All right, now the distance between these 2 points is going to be negative 3 minus a negative 2, quantity squared. Do you see where I'm getting the numbers? And then plus 3 minus a negative 2, quantity squared. The square root of that whole thing. Oh, dead marker. Negative 3 minus a negative is plus a positive, so negative 1 squared is 1. And 3, oh dear, did I do that right? Yes, this is positive 3. So now 3 plus 2 is 5 squared is 25, and I want the square root of that, so the square root of 26 which I can just leave. And now the third side is from here to there. So I'm going to take negative 3 minus 2 quantities squared, and then 3 minus 1 quantities squared. Do you see where I'm getting the numbers? And are you going faster than I am probably? All right. All we're doing is taking 2 points at a time and putting them into the distance formula to find out the lengths of 3 sides of a triangle. So negative 3 and negative 2 is 5, squared is 25. 3 minus 1 is 2, squared is 4. The square root of that whole thing, the square root of 29. So now, all we're going to do is we're going to compare the 3 sides. Our first side was 5, next one was square root of 26, next one was square root of 29. So I know that my triangle is scalene because the 3 sides have different lengths. All right, so it really and truly is just more practice using the distance formula. All right, so find the distance between each set of points, and that'll give you your 3 sides of your triangle, and then you could determine if they're all 3 the same, if 2 of them are the same, or if they're all 3 different. All right, let's see, one more thing before we do something actually a little more difficult. Midpoint of negative 2, 3, and 4, negative 2. So now this is different. This we've got a line segment, and so these are 2 endpoints on my line segment, and I want to know, well, what's the middle of this line segment? So what point is in the dead center? So then we're just going to use our midpoint formula. So the midpoint is, we're going to take the x values, and we're going to add them and divide by 2 to give my new x value. So negative 2 plus 4, all divided by 2. And then the y values, you're going to do the same thing. 3 plus a negative 2 divided by 2, and that's going to be my y value. So now just simplify it. 4 minus 2 is 2, divided by 2 is 1. And 3 minus 2 is 1, divided by 2 is 1/2. So my midpoint is 1/2. So 1 to the right and half up. Easy sneezy. Okay, so really and truly just to find the midpoint, you're going to use that formula. Now, the whole reason we did all of this and remembered how to use all of this is so that we can find, we're going to put them all together. I want you to find the equation for a perpendicular bisector of a line segment. So what that means is I've got a line segment, and I want a perpendicular bisector, which means a bisector is it cuts it in half. Perpendicular means it's at a right angle. So I've got a line segment from here to here, and I'm going to give you points. Let's do 5, 4, and what was the other one? Negative 1, 6. Okay, so this one is, oh, well, they're not very indicative of where they are, but let's just say this is 5, 4, and this is negative 1. Oh, that would kind of work. Not really, but that's close. Okay, 5, 4, and negative 1, 6 are my two endpoints. What I'm looking for is, I'm looking for the perpendicular line, whoop, that cuts that line in half. And if I could draw straight, you could tell a little better what I'm doing there. Oh, and that's made it even worse. Okay, you get the idea. Here we go. So here's the steps that we're going to take. Number 1, we've got to find, well, what is the midpoint? What is that point where I'm going to cross my line segment? So number 1, you're going to find the midpoint of these 2 points. And we just did that. We're going to add the x's and divide by 2. And then add the y's and divide by 2. So 5 minus 1 is 4, divided by 2 is 2. And 4 plus 6 is 10, divided by 2 is 5. So there you go. Step 1 is done. There's my midpoint. Step 2. So now we know where the midpoint is. It's at 2, 5. Now I need to find the slope between these 2 points. Do you remember how to find the slope? The slope, you remember, is the rise over the run. So it's the difference of the y's over the difference of the x's. So it's going to be your y minus your y over your x minus the x. Remember that? So your slope formula is y2 minus y1 over x2 minus x1. So if you need to put that in your notes, we didn't have that before. So this is going to be 6 minus 4 is 2, and negative 1 minus 5 is negative 6. So negative 1 over 3 is my slope. Done. Step 3. Now what we've done is we have found the slope for the original line segment. We need now the slope of the perpendicular bisector. And if you remember, a perpendicular line has the negative reciprocal of the slope. So this line, this new line, is going to have a slope that is the negative reciprocal of this line. So my new slope is going to be the opposite of this one and its reciprocal. So it's going to be positive, and it's going to be 1/3 flipped. So this is going to be a positive 3 is going to be my new slope. Easy. All right? Step 4. So now we have a midpoint. We have the original slope, and we got the original slope so that we could get our new slope. And in the last step, all we're going to do is put that information together. We're going to use the point slope form. Now we have a point on the line, and we have the slope for the line. So now we can use, do you remember the point slope form? Do you remember that point slope form is y equals, what is it? What is it? Because we use our slope, y1, no, it's y minus y1, not just the y. Y minus y1 equals slope is the mx plus b. So y equals mx plus b is your point slope form, but we don't have that point. So it's going to be y minus y1 equals the slope times x minus x1. All right, so y minus our slope is 5. Y minus 5 equals, not slope is 5. The y of the point that we know, the y value of the point that we know is 5. So y minus 5 equals the slope, which is our m, times x minus 2. So now we simply solve through and solve for y to get it into the y equals mx plus b format. So we've got to multiply this through first. Y minus 5 equals 3x minus 6. Add 5 to both sides. So our final answer is y equals 3x minus 1. So all 4 steps, quick, easy, for this final answer. Okay, so you're probably going to want these 2 formulas in your notes also, just to remind yourself, ooh, what do I do? I remember now. Okay, so the y minus the y from your point equals the slope that you found times x minus the x from the point that you know on your line. And then this is the slope of the line. So all of that is stuff that you know how to do. We've done before. So all we're doing is putting all these things all together into one lesson. I think that's it. Don't forget your distance formula, your midpoint formula, and I'll see you later.